All right, so we wanted to do this example where we graph f of x is twice sine of pi over 4x plus 2.
Yeah.
Okay, so first things first, I need to figure out what are the bits and bobs that make this function up, right?
Yeah.
So bubble diagram?
Sure.
Okay, so if you put an x in there, what is the first thing that happens?
Pi over 4. Multiply.
Multiply by pi over 4. Cool. All right, so log. First things first, multiply by pi over 4. Then what? Then we're going to sine it. Right? We're going to feed the result into the sine function.
Yep.
Right.
Then we're going to multiply by 2. Then we will
Add 2.
add 2. Okay, so where's your rule?
Sine.
Sine's the thing I recognize how to graph. Good. So which things are happening before the rule?
Pi over 2. Or pi
This
over
stuff. Multiplying by pi over 4. So I'm multiplying, which means I'm in what?
horizontal compression.
Okay, so this is a horizontal compression by a factor of pi over 4. It's a bit weird to call this a compression, right? Because pi over 4 is smaller than 1, so this is a little bit of a stretch, actually. You guys see that? Okay. Then this thing's the rule, right? Okay, so this stuff is happening after the rule, right? So what's this multiply by 2? What's that thing?
Vertical stretch.
That's a vertical stretch. And this plus 2 business, that's a
Shift up.
That's a shift up. You guys cool with this?
Yep.
Okay, so those are my steps. So now, how do I graph this thing?
Well, you start with.
Start with a regular sine function, right?
Mm-hmm.
Okay, so sine is one of these guys, and it goes through the origin, and is how tall?
1 to -1.
1 and -1, and where are the interesting bits and bobs?
Pi over 2.
Okay, pi over 2 is the first lump, pi is the first intercept, 3 pi over 2 is the next bottom of a lump, and
2 pi.
2 pi is where it starts repeating, right? Because that's the period of the regular old sine function. You guys see that? Okay, now what? I'm supposed to horizontally compress, right?
Mm-hmm. Well, stretch.
Yeah, stretch, right? Okay, so how do I make that happen?
Multiply pi over 4 by 2.
Let's see, so this thing was going to happen when I fed pi in, right?
Mm-hmm.
You guys see that?
It crosses the axis at pi over 4.
So,
I mean,
pi over 2.
Let's see, so I still think it's going to look roughly like this, right? Zero's not moving.
Yeah.
So what am I doing with this? I should be adjusting the labels on the x-axis, right?
So pretty much it curves at pi over 2.
Let's see, so this was going to happen when I put pi into the sine function, right?
Yeah.
So what do I put into that to get pi out? Like what goes in
4.
here to get pi out?
4.
4. You guys see that?
Mm-hmm.
That's me taking these labels and dividing by pi over 4. You guys see that? So that happens at 4, this happens at 8. This guy and this guy are at
2 and 6.
2 and 6, respectively. So is that a slight stretch out? Like I thought it was going to be?
By like 0.4 or something.
Yeah,
it's
but
something
just a
weird.
little bit, right? You guys see that? Okay, so there's my new relabeled picture, right? I horizontally compressed, which amounts to a slight stretch because this number is smaller than 1. Okay, then what?
Then
Oh,
you-
wait, I'm sorry. I forgot these. How high is this thing still?
1 to 1, still.
Still 1 tall, right? So now I need a what?
Vertical stretch.
Vertical stretch.
It's gonna get pushed up.
Just a very side
Okay, which should be pretty easy, right?
1 times 2 is.
I just need to draw the same picture again, right? Keep my labels on my x-axis, and what am I changing by vertically stretching?
Just the height.
Yeah, just the y-axis labels, right? So what do these become?
2 and negative 2.
2 and negative 2.
Mm-hmm. That's it.
And then I'm going to shift up,
Like 2.
grand finale here, right?
Zero becomes 2.
Oh, yeah. Okay. So 0 is going to become 2, so I really could just do this, right? The new x-axis is going to be down there. So I think I need to go, all right, we're going to start at 2. We're going to go up to 4. Then we're going to go down to 0 and back up and blah, blah, blah. Cool. Where is this top happening? Still at 2?
Mm-hmm.
What's happening here?
4.
Yeah, that's going through the point 4, comma 2, right? Where's this x-intercept now? Yeah, that's now at 6. And what happens at 8?
It's
Yeah,
like,
it's in the
yeah.
middle again. It's crossing that line 2 again. You guys see that? Okay. I'm going to just throw the other 2 words we were supposed to learn in here right now, because you guys have been using them this whole time. When I asked, how tall is it here? And you were saying 1, right? And then I asked, how tall is it here? And you said 2. You guys see that?
Yeah.
How tall is this one?
4.
No, it's still 2.
No, it's still too tall, right?
Because it's
You guys see
from-
that?
Yeah.
So that concept of how tall is it, right? What's half the distance from the top to the bottom? That's called the amplitude. Okay, now, to even talk about the amplitude, I probably should talk about the, what's the other thing that's happening here? There's this like,
Midline.
Midline.
yeah, that kind of spot it's oscillating around, right? That's the midline. So here at the beginning, my amplitude was 1 and my midline was 0. Here my amplitude was 1 and my midline was 0. Here my amplitude was 2 and my midline was 0. And now at the end, my amplitude is 2 and my midline is also 2. You guys see that? So what changed in the beginning here? What did I change from this to that? It wasn't the amplitude or the midline, it was the period. Right? The period got divided by the thing we multiplied by.
Yeah.
You guys see that?
Yeah.
So the old period here was 2 pi. And the period here after my horizontal compression was 2 pi divided by the compression factor. You flip that over, you'll figure out 8. Right? Notice 1 cycle and 8 units. You guys cool with this?